Line 22, 7B222, SM Higgs, CMS, Z boson decays, angles create mass, 2 muon force carriers, Wow Seti. There's the alien radio signal. And CMS detector event 2012, a proton-proton center of mass energy 8 TeV. The decay of SM Higgs boson to a pair of Z bosons. One decays to a pair of electrons, the other decays to a pair of muons that create mass and affect the electron, jet hadrons, and towers. A standard model background process theory, angles at 45, 7, 33 degrees in the signal show the effects in the line 22 Wow data. Again, another big mouthful. So I'm going to just make this diagram just a wee bit smaller so we can fit on the camera here. And of course it's not going to let me because I got too much. Oh, I can just fit it. Just barely. Hold on. Something is making it too big here. So we're just going to make all these little diagrams just a wee bit smaller, and I apologize. I seem to forget that my camera, I can never remember what size to make it. Okay, so let's go back up to the top here. So line 221, fields, charge, particle, attractions, nodes, Higgs formula, Wow Seti was our previous learning experience. February the 5th, 2014, quotes and diagrams from the blog. Here's a Higgs event from CMS. Again, it's a detector in 2012 of a proton-proton center of mass energy of 8 TeV. And you want to look at the different signals of the red lines and the green lines and then the yellow towers and stuff, because that's what we're talking about. So the event shows characteristics expected from the decay of the SM Higgs boson to a pair of Z bosons, one of which subsequently decays to a pair of electrons, green lines and green towers, and the other decays to a pair of muons, red lines. The event could also be due to known standard model background processes. cms.web.cern.ch is the link. Here's a diagram of angles, acute angles. An acute angle is an angle measuring between 0 and 90 degrees. www.mca.k12.nf.ca. And again, we're looking at the same Higgs event. And we're going to look at the electron green lines and green towers and the muons, the red lines. Okay? February 6, 2014, my thoughts. The SM Higgs boson decays decay to Z bosons. One decays to a pair of electrons, the green lines and towers up there. Okay? And the one signal that at the top goes at a 33-degree angle. Again, I created an axis with my pen going this way, and then I measured it with how big the signal was from my pen to the signal, and then I matched it up with the angles diagram up here to come to my conclusions, which mirrors the bottom muon. So you see that this one's 33 degrees and so is this one. They're both going the same amount of degrees in opposite directions. So the towers of electrons go at 0 degrees, and then they fan out on the left side towers to a 33-degree angle, which matches the left side of the 33-degree angle muon. See? Both of these fan out from the line up to 33 degrees and up to 33 degrees. The bottom signal is reduced because the Meissner effect pushes the particle. Okay, sorry. Hold on. Back up. Okay, the second electron on the right side only decays from 0 degrees and fans out to 7 degrees on the bottom and 33 degrees on the top. The bottom signal is reduced because the Meissner effect pushes the particle from its supposed 33 degrees up to 7 degrees, making a difference of 26 degrees. The top signal also affects the fanning out of the green electron towers to 33 degrees instead of 45 degrees, which is a difference of 12 degrees. So what I'm talking about is, look at this diagram. You have your muons on this side, and what does it do to your electrons? It makes the signal smaller. On this side, the muons are not there, and look how much bigger the fanning out is. Okay, that's what I'm talking about. So we can, in theory, say the bottom muon signal is a force carrier. It must have mass in the muon, and it creates a repelling force to make the other signal move towards the 0 degrees and stop it from fanning out. Would this then be considered a zero rest mass because it didn't fan out to 33 degrees and match the other signal? This is creating particle symmetry and its behavior patterns. And these are questions, right? The Z boson decays to a pair of muons. The red lines, top one's at 45-degree angle, the bottom one's at a 33 degree angle. I'm going to Google an idea. Keyword, carrier particle 26 degrees to see what comes up in the next video. Thanks for watching.